Guys, welcome to our next video, and today we're going to be doing some GCSE physics. In particular, we're going to be talking about magnetism and electromagnetism. So what is a magnet? A magnet is a material or object that produces a magnetic field, and a magnetic field is a region where a force acts on another magnet or magnetic material. So a magnet will have two poles, north and south, and an important thing to note is that the magnetic force is strongest closest to the poles, and unlike poles attract, as you can see at the top, whilst like poles repel, as you can see at the bottom. What is a magnetic material? It's one that is attracted to either pole of a magnet, so north or south, and examples of magnetic materials include iron or aluminium or nickel or cobalt. What is a permanent magnet? A permanent magnet is one that has its own magnetic field, which, you guessed it, is permanent. So you can't turn it on or off. Another important feature of permanent magnets is that they repel other magnets. So that's permanent magnets. What about induced magnets? What are they? So induced magnets are ones that only become a magnet when placed in a magnetic field. So if they're not in the field, it's not a magnet, and they're also not repelled. So with magnetic fields, we can't see them, but we can detect them, and we can detect them using a magnetic compass. And what that magnetic compass does is it points in the direction of the magnetic field of a magnet. And if we use a plotting compass, we can actually draw it. So what we have here is what a plotting compass would look like. And so, for example, let's take a magnet with a north and south pole, so a normal bar magnet. And what you do is you place the compass at different points near the magnet, and you'll notice that the arrow actually points towards the south, so it points from the north to the south. So if you look at all these purple arrows, they represent the plotting compass, and if you place them where they are, that's where they point. They point from the north to the south pole, and no matter where you place it, as long as it's within the region of the magnetic field, it will always point from the north to the south. And what you do is, if you plot lines, it ends up looking a bit like this. And one thing to notice is that the magnetic field lines never ever cross each other, as you can see. And also, the closer the lines are, the stronger the magnetic field. And again, finally, remember that the arrows always point from the north to the south pole. So that's magnets, but what about electromagnets? So the first thing that we need to understand is that when a wire has current flowing through it, for example this yellow wire, it creates a circular magnetic field around it, as you can see in the white. What is a solenoid? A solenoid is essentially a coiled up wire, and when current flows, the magnetic field created is similar to that of a bar magnet, which we were looking at just before. And as you can imagine, it creates a much stronger magnetic field than a single uncoiled wire would, because the wire is coiled. So what's an electromagnet? So a solenoid with an iron core is an electromagnet, and this core increases the strength of the magnetic field even more. So what might a simple electromagnet look like? Well, it looks like essentially an iron nail with a coil of wire wrapped around it and a current flowing through it. Now let's talk about the motor effect. So the motor effect is where a wire carrying a current interacts with another magnetic field, and that results in a force acting on the wire, and that force is at right angles. That's a very important point. So as an example, we have again this wire which is carrying a current, and remember that the magnetic field is circular. But when you've got another magnetic field, so remember how opposite poles attract, so they're going to create their own magnetic field, and the result of this is actually a force at a right angle, as you can see. If the wire were going in the same direction as the force between the two north and south poles, there would be no motor effect force. The greatest force is only when it's at right angles, as we saw in the previous image. So how do we calculate the force that's acting? So we use this equation where F is the force in newtons, B is the magnetic flux density, which is basically the magnetic field strength in Tesla, I is the current in amperes that's passing through the wire, and L is the length of the wire in meters. And all you do is you substitute it into the equation. But slightly harder, how do we find the direction of the motor effect? It's quite harder, it's quite different than finding the force. So here's an example question where you might be asked the direction of the force. So we've got a magnet, we've got a wire passing through it, and we've been told the direction of the current. So to work out the direction of the motor effect force, we use Fleming's left-hand rule. So you get your left hand and you position your thumb, your forefinger and your second finger at right angles to each other. With your forefinger, you position it in the direction of the field, so the magnetic field, so that's from north to south. The second finger points in the direction that the current is travelling, so from positive to negative. And finally, the thumb is pointing in the direction of the motor effect, so it will give you the answer. And you can see here that if you align your forefinger from north to south and your second finger from positive to negative, your thumb will end up pointing away from you. And that's how you get the answer to the direction of the force. Thank you very much for watching.